Hello, hello. It's been a while. Sorry for that. It was busy, and yeah, I didn't really get into a lot of embedded stuff lately. But also, one thing that tended to happen is that a lot of the ESP32 Rust code kept on breaking with new versions. So I'm very glad I saw this announcement that there's a beta version of a 1.0, so hopefully once they get to a stable one, that will break a little bit less, because like all the demos I did for over a year, they pretty much all broken now, and I can fix them. But yeah, what would be the point if they keep on breaking? But what I wanted to talk about today, want to create a game controller on the ESP32 and Rust, so you can connect to your PC. Personally, I'm into flight simming somewhat, so and there is a bit of a community about self-building controllers. One particular one I would like to highlight is Authenticate, and that's a guy, British guy, who was building 3D printed controls for Spitfire. And with very high quality parts, with Hall sensors and proper bearings and everything. Uh, and yeah, I really like it. It's all open source, so you can just build it. But there is one thing that this thing uses as a controller, is a sort of standard controller here, um, and that's it works. It works fine. I bought one. It's not a big deal. But it's not programmable in any way, I think, uh, and it's also pretty expensive. No, not this one. Right here. So yeah, here. This is 42 euros or something like that. I guess plus shipping. So you're looking at about 50 euros for a controller, which is yeah, it's not nothing. So I was thinking like maybe we can use ESP32, which is much less, and also it's nice to see what can we do with programming it, or maybe you could add some features we otherwise couldn't, and just how hard is it. So for that, hardware wise, there are certain boards that have two USB-C ports, and that's kind of nice. I think you don't really need it, but having two allows you to connect it uh, to your computer, your gaming computer, but also keep your serial port connected, so you can just flash and run your program, and you can see how it behaves. Otherwise, you'll have to flash it, disconnect it, connect it to your game PC, then see what it does. And if it doesn't do what you expected, then yeah, then you need to figure out what went wrong, because you won't have any logs. So I highly recommend to use one of these boards. I'm not sure how much this is, but it's not ridiculous. It was maybe 12 or some 12 euros. I don't know. But yeah, you make life a whole lot easier then. We're going to make a flight controller with ESP32. I don't think we'll get to actually making the sensors for it, because then we need some sensors that will serve as an input. So I'll create some demo system that will just send a report to the gaming PC that something is happening. Uh, but we'll get to that. So, where to start? There are some places where we can start. One thing is we are always using Embassy pretty much. And Embassy has a USB crate, so that's pretty nice. And that's sending, yeah, that should be a nice place to start. Um, and furthermore, um, yeah, let's just start and see what happens. And I'll get back in here if needed. Okay, so let's Let's run ESP generate, so that changed as well. Last time I used the old templating thingy. This is a new one. You can cargo install it. It's a little bit quicker. It's a little bit nicer, but in the end, it's the same deal. You have to add a chip, ESP32 S3. I'm not entirely sure. If you know, please let me know in the comments. All the USB stuff seems to be the S3 chips. I'm not sure if it's really required. Can you do the same thing on a C3 or a C6? I don't know. I guess, but I would need to try. If you have tried and succeeded or failed, please let me know. Anyway, so this is an S3. We call it, let's call it ESP32 USB joystick async, something like that. Alloc, yes please. Wi-Fi, don't need it right now. Embassy, yes. Anything else? Nah. Official studio code is nice. Okay, let's save and go. So ESP32 USB joystick async cargo build. And yeah, I wanted to say something, I forgot. So so we can start to compile it first to see if there's any issues. I suspect there will be. And once we get it running, we'll look at the examples we find and see what we need to do to make something happen. Yeah, here we go. This is one of the things that keeps on happening, right? So this is incompatibility between the Extensa crate, I think, and Rust compiler. So the Rust compiler was updated. It's using the, obviously, let me show the Rust toolchain. So it's using the ESP channel. So yeah, it got updated, and then this version of the template doesn't work anymore. I didn't dive into it a lot, but yeah, these are always kind of unpleasant surprise. I think if you're doing something, the most basic thing you can imagine, just setting up a project and compiling it, and that it fails immediately, kind of sucks. So what do we need to do to fix this? Well, I've tried before, and this one, the 20, it's a bit small maybe. Yeah, the 22 version is a little bit, yeah, it's obsolete. So if we bump it to 23, it will solve this. It will also involve bumping some other things, but not sure. I'm pretty sure we need to update embassy time. Let's see what this does. But yeah, I hope that once we hit 1.0 for the health, ESP health, it gets a little bit smoother than this. Because yeah, I've dealt with this a bunch of times, and then you get over it. But I can imagine if you're just getting into it, these kind of things are annoying. Okay, yeah, some minor things, changes that we can fix. It's not a problem. So I guess the prelude was removed. So let's just find this. Embassy main. It's complaining about spawner now, so I think there is a mismatch somewhere. Let's see. Let me check in crates.io, see what's the latest version of this. 7. Maybe I have to go to 7. And did I bump the executor? Let's see, execute. Also at 7, is that correct? Let's see where this one leaves us. What is it saying? Okay, so now this one is pointing to the beta just since yesterday. Okay, so I guess this was the ESP HAL embassy. I need to push back 1. Let's see what this does. Okay, I think we're getting there. So the error that it said that that spawner was not the right type, that usually means there is some mismatch in dependencies or something that moved around. So this seems more straightforward. This is just a matter of getting the right import. I guess it used to be in the preludes. This thing is also changed. These changes you can usually find in the migrations part of ESP HAL. So if you look at crates and let's check the GitHub repository, and there's always a file. Where is it? ESP HAL migrating, and then yeah, it lists all the changes that are there, and usually you'll find the problem. So if you update an old project, you'll have to go through them in order to fix all the things, which is tedious, but I'm really glad it's there. So I guess the split thing is here as well. Maybe it isn't. Or maybe it was changed before. I don't know. But this, I think this is a little bit easier now. I think you can just instantiate this thing now. Yeah, I think this does it. So you just make a new system timer with a peripheral in it, and then you can initialize embassy with alarm 0. Let's see if my actual device works. So I need to build it with release. And hopefully we see our familiar hello world loop now. Oh, and then run it, obviously. Okay, so it works. Well, it doesn't do much, but what it does works. So we have this loop going, and apparently our build is valid now. So let's have a look at the actual USB stuff. So there are two things we need to look at. First of all, there is a setup for in the ESP held folder here to set up just USB serial. So that's on the USB level. And that's pretty straightforward. So I guess we can just copy paste it. We take we instantiate the USB object. We put in the peripheral. Pin 20 and 19 seems to be where mine are too. I didn't really find much in the wiring, but apparently maybe that's some kind of standard. I'm not sure. We create a buffer, a configuration object, a driver. I think the driver is on the Embassy USB side. No, that's in the ESP HAL side. So there's an async driver there as well. This is the actual driver for the USB chip, I think. Then you can add the class, the protocol. I'm not very familiar with all of this, but we can at least start by pasting some of it in here. Now, wait, let's have another look at something I found in the Embassy crate. And this is an example of a keyboard. And USB devices that are used by humans is in a special class, and that's called HID, Human Interface Devices, I think. They have a standard protocol, so you can easily make something like a keyboard or a mouse or a gamepad, and you don't need to alter any programming on the game side, for example. You can just plug something in and it will roughly work. So let's have a look here. So this is an example of a Raspberry Pi RP or Pico, I suppose. But let's see if it's anything familiar. So it starts here with initializing device. That's different because we have on the ESP side it's just a bit different. But from here on, it starts to look a little bit familiar, right? Because once we have a device, the tricky part always is to figure out what's Embassy and what's the actual device, because that's obviously a little bit different. So let's start by initializing the basic USB thing. So I guess up to here. Create USB. Let's see what that does for us. So we initialized Embassy. And let's see what we need to import. Yeah, that's the tricky one. Which config is it? I guess it's it's in the OTGFS. Okay. So this one, and this should be in the OTGFS as well. So now we have that, and this is so this is on the OTGFS level. So then we need to look at how we are going to initialize Embassy. and that looks something like this. So we have to create a configuration. This one wants to create a keyboard. Then you create this state object. This is part of Embassy, I suppose. And then you have a builder. And then we get, this is, I think, kind of keyboard specific. We're not going to need that. And then finally you instantiate your USB, and then you kind of need to run it. It's similar to ESP Wi-Fi. You need to have a task to do its things, but I'll just use Embassy task for that when we get there. So let's move forward. So I'm looking again at the what do I want to do? Yeah, so this is a keyboard. We're not going to make a keyboard. So I did find something else, and that was on the USB DHID crate. Yeah, so this crate is also a dependency of Embassy USB, so it is in our tree. I'll show you. So where is the? I'm always amazed at how massive these trees are, given the how basic stuff we are doing right now. I don't see it. Why don't I see it? Let's see. So we have the kind of lost the train of my thought here. Let's see. We need to add this HID. So let's see how far we get to see if we have the right dependencies, because I suspect we might not. So let's do up until here. See if we can get this to work, sort of. So we have the driver. So this is clearly a different configuration. So that should be Embassy USB. I didn't add Embassy USB yet. Oh, that's done. I didn't? No, I guess not. Yeah, okay. Cargo add, that's done. So that's why I couldn't find it in the tree. Yeah. So let's have a look. So if we add Embassy USB, it will use that crate I just mentioned. It will has that as a feature for HID components and devices. So let's see what that brings us. ESP USB, Embassy USB. Yeah. This will create a keyboard example. Request handler, we all don't need that. State, I suppose that's HID state. The trouble with all those generic names, I mean, we make fun of Java to having huge long names, but these are nice and short. But on the other hand, there are 20 of them, and you need to know exactly which one. So this seems to all work, and from then on, what we will need to do to actually run it is to we can the builder we can actually instantiate by calling build, and then we have a USB device, right? And that you need to run. So that's as you can see here is a method that will never async method that will never return. So that's something you'll need to schedule in a separate task to yeah, keep running and just keep the bytes moving up and down, and then you can incorporate. So maybe you can just do that right now. So let's create a task. This is the standard embassy stuff, async function run USB, and we pass in the USB device. It needs a lifetime, so that's static, and the driver, that's I suppose a driver that also needs to be static. Let's see how that behaves. Okay. Let's see. So then we need to use the spawner. We can remove this one. So spawner, spawn. We can use must spawn. Then we don't need to unwrap. And then we call run USB with the USB device. That will give a bunch of lifetime issues. We'll fix it. Yeah, so what's happening here is that all these things we instantiate here will not have a static lifetime. Neither does this one. So there are some ways out of it. As I'm using alloc anyway, what I usually just do is box leak it. Box new. So that will move it to the heap, and seems to work fine for what we are doing. So something like that, and then we don't need the borrow, because like this will automatically create a mutable borrow that lasts forever. Then this actually doesn't need to be mutable anymore. So that's one thing, and then we need to do that for all these things. So a little bit boring. We just copy the box leak, box new. You get used to this. This one, this one, this one, and this one. Close it, close it, close it, close it. All these things don't need to be mutable anymore. We need to remove all the borrows. So this one is happy. Don't think this needs to be mutable. Not sure. But we did resolve all the build issues. And I guess this one neither. And then here we can call USB.run. And now the device should be up and running, and of course I waited. And we can also have this one not return. Let me say this, and this one needs to be immutable. Okay, so now we have a task to run the USB bus, and that seems to be all right. I mean, it's not still not going to do anything. Let's see. Let's just run it. See what it does. I don't think we'll notice much, but maybe you'll hear it connect to my Windows machine. It will give the USB sound, that it is somehow recognizing it. Upload it. Okay, so I guess it's working. I could check my USB device interface on my Windows machine, but that will take too long. So let's move on. So this was old keyboard, but we want a joystick, right? And the HID library, so that's the one I showed before, the USB-D HID, does support it, but not very nicely. And I found an issue there that's a little bit gnarlier than the keyboard one, but it is pretty straightforward. So this is an issue that it should be a better way, and then somebody says how you can do it, and then I think, yeah, well, that works. So let me just paste this in. I'll put it in a separate file and see if we can get this to work. Yeah, well, let's put a pin in that for a moment. So we are here. Let's have a look at the embassy part. So we'll need to configure the HID part. So we have a state, we have the builder. This we don't need. So this part, right here, we have a keyboard report, and now we'll have a joystick report. So we don't use that one, we use another one. Then we create a reader writer, or I think we can create a writer as well, because we don't need to read. And then this part we already did, USB build and run. And then the signal pin is just to actually use something like that. But this is the part we'll need to do now. So we need to create a config, and we'll create a HID writer. So let's just copy this in as well. So this we did from here on. So we don't want the keyboard report. We can import. Oh, it's not here. I guess we need to import USB-D HID then. And here's the HID stuff. So that is here. So this one, I guess we need to add a dependency, but we don't want the keyboard report anyway. So let me create a new file and call it joystick.rs. Include it here. And let's copy that example with the macro, this one in here. I guess we need to add the dependency, cargo add USB-D HID. Okay, let's see, I can find it now. Now it's here. Some other imports. I guess a prelude. Anything else? This one seems content right now. So we could create here a joystick. Oh wait, I think I did this wrong. This needs to be public, otherwise I can't see it. Alright, so here it is. Okay, let's do what it asks of me. Add import. Okay. I don't think we actually need to do the reader-writer thing. And the state is not mutable, so... Oh yeah, it was just in a weird spot. And then now it doesn't live long enough. So we have to do the same box leak trick here. So box let state box leak box new. Put this thing in here. Does need to be mutable. We just forgot this part. Okay, the builder. Okay, so I guess this needs to move after this one. The builder needs to be mutable. Typical Rust life. Okay, so now we have a reader-writer. I think we only need a writer. So let's see how that works. Hit writer, new, mutable builder, state and config. And I guess, yeah, it needs some type stuff. HID, writer, needs a number. I'm not sure what this number is actually. So it's a number of something. I've tried. It doesn't work with 1. So it says 8 here, so okay. And then remove this one. Okay, so now we have a writer object, so now we can write joystick reports to the computer. So what that would look like now is that you can do writer dot write serialize, and then you put in here a joystick report, something like that. Fill the things, or maybe borrow it. I think something broke. Just let me show an example. Let report equals joystick report. Fill the fields. So that is the X and Y. So something like 1 or 2, something like that. It's a signed byte. So it's a value between minus 127 and plus 127, 28, not sure. Something like that. This one is the same, we're not going to use it. And the buttons is 1 byte, 1 unsigned byte. And it's just 8 bits, right? So for every button, a bit if it's up or down. We're not going to use that one either. So it doesn't matter. Doesn't matter. And doesn't matter. So we just initialize everything to 0. We have a report. And then, let me clean this up. We can say, I guess, report, and await. And unwrap maybe, yeah. Writer needs to be mutable, fair enough. and now we can write the state of the joystick, and yeah, we can just do that, and basically we should be in business. Some more things to do. I'm not going to do any actual sensors right now. So what I want to simulate is someone rotating a joystick, like stirring the soup. So we have a basic input signal that looks like something. So let me create a new file for that. Let's call it demo.rs. So that's going to create a fake joystick in a sense, but that would look like a realistic joystick to the machine. So like here we're gonna no, not here, but mod demo. So let me show me my thinking. Let's create a struct, and we call that a rotator, modeling our virtual joystick, and that has one field. Let's call it angle, the current angle of the rotation, and that's like a U32. Okay, and what I would like is that every time I ask the rotator for a value, I'll get a new joystick report that will show that angle. To do that, what's a pretty nice thing to do is implement an iterator for it. So what we're gonna do here for rotator, and then we need to fill it up a little bit. So we need to define what kind of thing we want to emit, and that's obviously a joystick report. And every time this gets called, you can create a new joystick report. It should never terminate, so I'll always return something, and I will update the angles to have a new angle. So what does that look like? We're gonna do some basic math, some cosines and sines. So first of all, we need to have an angle, but all the cosine and sine use radians, so we need to convert that, and we need to convert it to floats because right now we have an integer. So let's create a variable angle in radians, and that will take our own angle. And let me think. We need to convert it to float, but that's not there. So we need to add something because this is not standard. I think we need to add libm. No, num traits. Like this. Okay, so this added num trait, so that's like the basic math stuff. But it's standard now, and that's bad, I suppose. So I do it without no default features. And I do need feature libm because that's how you can do math on no standard things. Okay, this looks better now. Libm is activated and standard is not. Let's see if we can get this to work. Now this, it's still building. Let's see if we can find this trait. That seems to find something. So now we have a conversion to a float. and we can unwrap it, but we still didn't convert it, right? So then that's multiplying it by pi, I guess, and dividing it by 180. Dot 0. It doesn't actually matter that much, right? It's just as long as it's a kind of realistic thing that we're emitting. Okay, so we need to think about how big the radius will be of the circle we are making. So we need to stay within the 127 range. So let's create a float here. Let's go 110. Give it a little bit of margin. Dot 0. Sorry. And then we can create an x and a y. So it's 0.0 is the center, so we don't need to offset it or something. So let's go x. We take the radius times the cosine of the angel radius, and that should do it. What's it? F64. That's unexpected. Let's check what cosine does. I need to have the cosine F. Can't remember doing that before. Okay. Let y equals radius times and sine f, I suppose. And now we can create a joystick. So we need to create a sum because we're going to return something, and we can create a joystick report x, and we need to convert it to sine byte to I8, right, and unwrap y to I8 and unwrap, and we zero the rest. Okay, so now we have a thing we can call, and every time we call it, we get a new value. So let's run that thing. We create a separate task. Async function run demo. We create a rotator. Let's give it a default. Then it will initialize at 0. And then we can just do for report in rotator. And now we get joystick reports forever. I'm not sure if the reports are implement debug. I guess I can just do that. Debug. So we can okay, I guess the macro does it. So it already implements it, so we can just print it. And let's do info joystick report and then show it. And then maybe chill out a little bit. After 1 second. So now we can create a task to do that. Spawner must spawn run demo. Let's see what this does. Let's upload it. It panics. What happening? Main line 87. Okay, this is not really a surprise. What's happening is that it tries to write and sometimes it can't. Also because, for example, when the microcontroller starts, this is like in a millisecond or something like that, and then the host might not be ready yet, so it just starts writing, and sometimes it will fail. So that's all right. Let's disable this line for a moment because it was just to show what the report looked like, but we already went through that in the demo. So let's run it without this to see if it doesn't panic. Upload it. I forgot to increment the angle. That's dumb. Self dot angle plus is 1. Can you do it like that? I think so. So now the output should be slightly more interesting. Yeah, so now it's a little bit faster than I thought. Did I forget to await it? Because it's running really quickly. I should have put it inside loop. Yeah, okay. Anyway. So this will create joystick reports, and now we need to somehow send it to the device, right? So across from one task to the next. So now it calmed down a little bit, and you can see it will have, yeah, you can kind of tell it's starting to be a circle, like every time it goes a little bit clockwise, I suppose, and you get new values. So we are creating joystick reports now. So we need to communicate that to something that will be able to post to the actual joystick. So we need another task for that. Let's create a task. Async joystick USB writer, something like that, and that will take writer, HID writer with static, I suppose. And I think we already mentioned the driver somewhere, and that number. And this is also static. Okay, so we create another task, a spawn, and we do USB writer, and we pass the writer into it. Okay, and I need to have it mutable, of course. Okay, so we could write something to it, but we need to communicate between the two tasks. For that, let's create a signal. I'm not super familiar with them. I tend to use channels, but it doesn't really make sense here. Signal is a primitive where you share a value between two tasks, and you only share the last value. So you don't worry about dropping one or two if the USB writer would be slow or something like that. You just want to update the latest. So let's see. Joystick signal. That's a signal. I need to add embassy sync. Okay, I will add there all the synchronization things reside there. I guess the version is alright. Signal. Here we go. You need to have a raw mutex, I think. Oh Jesus, what is it called? It had a name. Let's start with a no up raw mutex, but I don't think that's gonna work. And then what else does it need? And a type, of course. And the type is a joystick report. And then no, not const, static. Yeah, that was what I thought. It's not the right mutex. I'm blanking on the name right now. Let's see if I Google it. The raw mutex is critical section raw mutex. Okay. That should resolve this, I think. Yeah. Okay, so right here in our rotator thingy, we can go to our joystick signal, and we signal with our report. And here we can, of course, loop. And I guess this one doesn't need to return ever either. And we can do writer dot write serialize joystick signal dot dot wait. Is that how it works? Does it just want to? Oh yeah, that's weird. No, I'm kind of blanking on how signal works. Isn't there some kind of get? Well, let me quickly look that up. Embassy signal. Some signal we created. This is pretty much exactly what we did. How do you get it out? Try take, is that what we're supposed to do? I mean, there will be pretty much always one in there. Or wait. Yeah, we can wait for it, I suppose. Okay, so this would indicate that we just do wait and await. And then borrow it. And then await again, I suppose. Yeah. Okay. So now we have a loop that will... okay, let's unwrap it as well. Just to be sure, let's chill out a little bit. I think it will get paced by the host anyway. Okay, this one seems to work. Did we spawn it? Yeah. Okay, let's see what it does. Did I? So now it says HID keyboard example. That's a little bit lame. Let's update that. And it also panicked. Where did it panic? Oh yeah. It's basically the same thing again. Oh, actually now it says that my USB device crashed. So my Windows PC noticed there was something there and then there wasn't. So that's kind of nice. We kind of messed up the same place because we shouldn't unwrap it, because it can happen that the write fails. And we need to fix that configuration to make it nice. So manufacturing, my channel, flatline. Let's call the project Frank's joystick. One thing I found out is that if you change anything from this, you need to change these as well. Otherwise it will, I think Windows caches them forever otherwise, so it won't show up. And the other thing we needed to fix was the remove the unwrap of the write. So let's do it like this. We await it and we match on it. So then if there's okay, we don't do anything. If there's an error, we complain a little bit. And then just keep on trying. So we do warn, for example, write failed. And we include whatever the error was. So now we can at least tell. Okay, I forgot to remove the 1 second delay, so it's a little bit slow. Let's see if I can find my game controller in my USB and see if I can show you that. Yes, there it is. It says my device is ready. Frank's joystick is set up and ready to go. That's nice. Let me show it to you. So that's right here. You see, the rudder pedals have nothing to do with anything. Let's see if I can get some properties. Oh, it's not really showing. Let me do that again. I need to get the exact right window. That's a little bit of OBS magic. Here it should be. So now it shows the location. It's really slow. Let me increase the speed a little bit. Because here this thing is a bit much. I don't know, something like that. 10 millis, is that ridiculous? I think it's fine. Probably need to redo that screen again because it will reconnect. I see it's vanished now. And now it's back. Yeah, I have now the wrong window. One moment. Let's do that one. No, still getting the wrong window. Let me see. And then, look, now you see the joystick controller making a circle. Cool, right? So, yeah, that's what I wanted to do. This is not very spectacular to look at, but I do think it's nice that we created the controller now and just Windows recognizes it without anything special. So I think it's a nice place to start. To have some actual eye candy, I set this one up in DCS as well. I'm not going to, I recorded that because otherwise it's going to be too complicated. All right, so I set it up in DCS. I had to re-record this part because the audio level of the DCS was a bit high, so I was literally standing next to a jet engine. But yeah, so it works just fine out of the box into DCS. It will recognize it as a joystick, and it works totally fine. And you can configure it, but you don't need to. So I think that's really cool that it just works. Yeah, we talk about running out of the box, batteries included, but it rarely works like that. There was quite a bit of work to get where we are now. It wasn't as straightforward as I might have made it seem because there were a few false starts. But yeah, thank you for hanging out with me, coding a little bit, and see you next time.